Hello viewers, I am David the Nurse. Thank you for watching my YouTube channel. If you are yet to subscribe, please press the subscribe button so that you receive notification for my subsequent videos. In this video, just as it has been projected, I will be talking about high flow nasal cannula. High flow nasal cannula. This is a special device and it is different from the ordinary or the usual nasal cannula. I've explained the common nasal cannula in my previous videos. You can just go back and check if you have not watched it before. There are three distinguishing factors about the high flow nasal cannula. The first one is that the air is heated. It is heated to the core temperature of the body or near heat. So the air is heated to 37 degrees Celsius. Now, the rationale behind that is simply that when air is heated, it becomes lighter. Cold air is weightier or denser. Heated air is lighter. So that is the rationale. Because it is high flow, it is expected that the air is heated up so that the speed of the flow of gas will be increased. So it's heated up to about 37 degrees Celsius. That is very important. The air is also humidified. Humidification is important in order to prevent any form of dryness in the airway, which can lead to inflammation or excoriation, irritation of the airway. So it's humidified to about 100%. It has 100% relative humidity, and that will be sufficient for the airway. And then, just as the name implies, high flow, it can deliver up to 60 liters per minute flow rate. It can deliver as much as that, 60 liters per minute. So it can go as far as that, which means patients in need of high respiratory support can benefit from high flow nasal cannula. And these features, they help to perform the function of the nose, because in normal respiration, when you inspire air, the air is heated up in the nasal cavity and then the air is humidified, which makes it very conducive for the respiratory tract. Let's move on. Now, this is how high flow nasal cannula looks like, and this is the air chamber. Here is a flow meter, and here is where the FiO2, fraction of inspired oxygen, will display. So as the flow meter is adjusted, the FiO2 also changes to that range or value at which the flow meter is set. All right, and this is the air chamber where oxygen mixes with air, which it's always known as air entrainment, because delivering 100% oxygen alone to the patient is harmful to the patient. So there needs to be a mixture of air with oxygen, which we call entrainment. So the area where there is mixture, that's oxygen air mixture, is the chamber, and that helps to give the healthy air to the patient. Now, this is the complete high flow nasal cannula system. This is a complete one. Let me just, okay, this is a complete one here. So I have explained this area. So this is where the source of air is coming from. The source of air comes from this area. Then it flows through this pipe down. Now, when it comes here, this is the humidification system here. This is where distilled water is poured into to supply for humidification, to humidify the air. And this place is the heater. This is the heater. Okay, so is the air is heated up. The humidifier here is placed on the heater. Okay, so both processes work together. The air is heated and the air is humidified. Now, the humidified and the heated air now move into this chamber here, and then that's what goes to the patient. So that is how the system works. It's as simple as that. This is the air chamber. This is where the flow meter is, and then the FiO2 displays here. I explained initially that the air chamber, that's a mixture, air oxygen mixture, takes place in this place because this is the source of air. So the air moves on and then comes here. In this area, there is humidification and there is heating of the air. So the air is heated and humidified. The humidified and the heated air moves to the inspiratory valve. This is the inspiratory valve, that is the valve that conveys air into the patient. So patient receives heated and humidified air into the system. Okay, so and that is it. So let's move on. Okay, so this is how it is applied. Now, looking at this looks like the normal, this one here looks like our normal nasal cannula. All right, now this is how high flow nasal cannula looks like. It's bigger compared to the ordinary nasal cannula. Look at the prongs. Look at these prongs here. You can see that is larger in diameter compared to the usual nasal prongs that the patient uses. Now, it is larger because the intent is that these prongs will fill up the holes, the nares of the nostrils, will fill it up without leaving any space. That is very intentional so that patients will take in sufficient oxygen. And because it is high flow, it's up to as high as 60 liters per minute, it needs a larger diameter to convey such a rate, high flow rate of oxygen into the patient. And you can also see this inspiratory valve, the tubings here, they are also large tubings. And this is how it is attached to the patient. Okay. Then moving on. All right, that is that. I quickly want to intimate you about a training that will be taking place between 11th and 13th of September. That's Ecg Training. If you are interested, please just contact this number here. It will be very, very interesting session. We offer you certificates and course materials and other visual aids. All right, and also